Hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet. Okay. Now we are looking at this question 7. It says, consider the two charged spheres, A and B, below. So what are we looking at? We are looking at A representing a sphere and B representing another sphere, and separated by this length. Then the question comes and it says, calculate the magnitude and direction of the net electric field at point P. Okay, let's look at how we can approach this. And please don't forget to subscribe. The channel is Physical Sciences Silver Bullet, and it's me, Richard. Okay, what do we know? This is what we know. We know that this sphere A has an influence at P. So it has an influence in terms of electric field at P. And sphere B has an influence also at P. So the interaction between the two electric field creates what we call net electric field. Okay. So what do we do? Let us first look at this one. The electric field at P due to A. Let's look at that one. So there we are. Electric field at P due to A. Okay. It's given by E, given equals to KQ over R squared, where K is 9 times 10 power 9, and Q is the charge at A, which is equal to -2 times 10 power minus 6. And the intermediate distance between A and P is the sum of these two, 0.5 and 1 meter. So it's going to be 1.5 squared. What we get here will be the electric field at P due to A. So this is what we get, 8,000 Newton per coulomb. So what is next? What is next is going to be the direction. I want you to remind you that it's the point P is positive, like any other point. And we know that our A is negative. So what do we see here? We are seeing that, remember, it's point P which is going to move. So where does it move? It's attraction, because of this being oppositely charged. And attraction means P moving to the left. And I have to remind you that if we chose to the right to be positive, then to the left is going to be negative. So movement of P towards A is negative in direction. So this electric field is negative. So what comes next? What comes next is going to be electric field at P due to charge B. Let's look at that. So there we are. Electric field at P due to B. Okay, how do we get it? Okay, we go by the same formula, which is E is equal to KQ over r squared, and k being 9 times 10 power 9, and q being 2 times 10 power minus 6, and the distance between b and p is 1 meter squared. What you get out of here will be the magnitude of that electric field. So yes, we get our answer as 18,000 Newton per coulomb. Okay, what is next? Next is the direction. Okay, we have to recall that B is negative. And you have to know that it's P which is moving. And because they are oppositely charged, there is attraction. Attraction means that P is moving towards B, and that motion is negative. So we are having this electric field as a negative. Okay. What comes next is going to be our net electric field given by E net equals to E1 plus E2. So assume this one is our E1 and this is our E2. What do we do? What is next is going to be substitution. So let's substitute and see. So after substitution, that is what we get. 26,000 Newton per coulomb. Negative, actually, 26,000 Newton per coulomb. What does the negative imply? It implies to the left. So you can drop the negative and simply say 26,000 Newton per coulomb to the left. So there we are. So let us go to the next question. Yes, then comes this question. It says, calculate the number of electrons that should be removed from B so that the net electric field at point B is this. It is this to the right. Okay, how do we approach this question? We have to know this. Okay, things have changed. A is unchanged. So A is influencing this point P. And that one has not changed, but B has changed. Actually, B was negative. It had excess electrons. Now they are telling us to remove electrons, to pump them out until this electric field at this point becomes this. So under the circumstance, what do? We know our innet, the new one. So our innet is 3 times 10 power 4. Okay, not minus 4, it's power 4. And to the right. To the right means what? To the right means positive. Remember, this is to the right. Okay. Then what else do we know? We know E at P due to A. So that one remains unchanged. It is negative 8,000 Newton per coulomb. Yeah, even this one is Newton per coulomb, you must not forget. So that's what we have. That's what we have. That those two informations. So how do we use them? Okay, we know that what we don't know is B. The moment you distort B, we don't know it. So what do we do? What we are going to do is to find E at P due to B, the new B. To get that one, we need this equation. It says E net is equal to E1 plus E2. Where E net, we say it's 3 times 10 power minus 4, power 4. And suppose E1 is due to A. So we already found it as 8,000. And now we know E2. Okay. So E2 we can get it through rearrangement. Yeah, there comes our E2. Our assumption that where E2 represents the electric field at P due to B. Okay, so what do we do under this circumstance? We go ahead and get the new charge at B. How do we get it? Through the equation, which E is equal to KQ over R squared. Here our E is going to be our E2, which is 38,000. Okay, then K is 9 times 10 power 9, and Q is wanted, where the distance has not changed, so it remains 1 squared. So when you look at that expression, the only unknown is our new charge. So our new charge is going to be equal to, so there we are. And our new charge is this. Okay. Now, after getting our new charge, what do we do? What we do is that we are going to find the difference between the new charge and the charge before. Let's look at that. So this is what we have. The difference between the two charges is equal to number of electrons transferred times the electronic charge. What's the difference? We are going to say the charge final minus the charge initial is equal to NE. What is the charge final? We have it here. It is 4.22 times 10 power minus 6. And what is the initial charge? We must remember that this charge is positive. Why positive? We must remember that our E, the electric field due to the new charge here at point P, was found to be positive. Okay. What does positive imply? It implies that this electric field here, the charge here, is making our point P to move to the right. Now, which charge when pressed here, will make our point P to move to the right. Remember that movement is repulsion. This charge must be positive. So in other words, what we have here is a positive charge. So our initial charge is, so our final charge is positive. So what are we doing? Our initial charge, the charge before, is minus 2 times 10 power minus 6. This one gives you a number of electrons times electronic charge, which is 1.6 times 10 power minus 19. Okay, let's see what we get. So this is what we get after computing this. It is 6.22 times 10 power minus 6, giving you that. And here the only unknown is our n, which we can find. Let's find that one. So there we are. And we found the number of electrons as this 3.89 times 10 power 13 electrons. So that's what we are supposed to do on that one. And with that, we are going to close this video. We thank you for your time. The channel is PSSB. It's me, Richard. Don't forget to click the like button and also to refer the channel to others for subscription. We thank you for subscription. See you next time. Bye-bye.